We're given electron configurations here, and we're asked to find the symbol of the atom. You could just, for all of them, just count the number of electrons. That's 2, 4, 10, 12, 18, and be like, oh, that's argon. Well, there's your answer to that. I doubt that's what they wanted you to do. They probably wanted you to correlate the electron configuration to the blocks on the periodic table. So if we were to give you a question like this on a test, which we could, we would we would not even give you the first several and be like, maybe just give you the last three, and then that way you can't count the electrons. You gotta connect it to the sections on the periodic table. This happens to be a violation of alpha-val, right? Like I said in class, there's about 20% of the periodic table violates that. So maybe this one might have been easier to actually count them now that I just said that. But let's go do it. And on top of that, let me just unerase this. So this format, they put all the fours together, all the principal quantum numbers they put together. Right? They put the ones together, twos together, and threes together, and fours together. I mean, sometimes you'll see that. In other words, this is not in order of the periodic table. So you can't just be like, oh, whatever is the 5s1, that's the answer. It's not. Right? Because you already know the 5s, let's just go through. These are the two unfilled ones. Let's just go there. All right, 5s. Here's your 1s block. We're done there. 2s there. 3s. 4s. And this is your 5s. We're here on the periodic table, right around here. We're right here, actually, 5s1. And then we go to 4d7. So this is your 3d, right, block right here. And this is your 4d block. I should get a blank here. I'll be right back. Okay, this is much easier. All that other, we didn't need all that other text on there. So here's your 1s, 2s, 3s, 4s, 5s. Okay, so we're like right there. This one's empty. And then went to 4, so this is 3d, and this is 4d. All right, 3d's there, 4d's there. You might be like, well, why this guy's just making stuff up. No, I'm not making stuff up. Because remember, in the first, when n equals 1, there's only the s. When n equals 2, you got s and p. All right, every n, you get new orbital, new shape available. S3, right, you got s, p, and that's for the first time you have your d's. That's why I know when you have the first d block on the periodic table, it can only be available in the n equals 3. So that's why I'm saying that. So there's 41, 42, 43, 44, 45, 46, 47. And we're right here. All right, now let's take one away because that one was not accounted for. So our answer is going to be right over there, whatever that is. 1, 2, 3, 4, 5. The sixth spot on the 4D. 1, 2, 3, 4, 5. Here's your answer. Is ruthenium. It's one of the platinum metals. They're all very similar and used for catalysts. We'll talk about that later. All right, ruthenium. That one might have been easier just to count up all the numbers. Go figure. After I tell you, you probably shouldn't do that. Yikes. What do we have here? And they grouped all the orbitals by principal. So it's all out of order. I mean, it's in order of the principal quantum number, energy level, but it's out of order in terms of what we want it to be. Like, we can't just go to 6s2 and it's like, boom, there's your answer, because they reshuffled it. So we know the unfilled electrons going to be right there, or unfilled orbitals, rather, and right there. So let's go there. All right, and the one before that's going to be 6s. So let's just start at 6s. Okay, 6s2, right? We're just going to go one more here. Here's your 6s. That's filled. Never explained this. You're not going to get this question on your test. All right, but these are intertransition metals. They actually go right in here. So after 6s, right? So this is 4d. I'm going to rewrite that here. This is 5. This is 5d, and then now this is. Well, you tell me, where did the f start? Because that's what this is. All right. I hope you said 4f. That's your 4f. not both of them. That one is your 4F, and that one is your 5F. Where did this end? 4F7. Okay. All right, so we're here 4F1, 4F2, 4F3, 4F4, 4F5, 4F6, 4F7. Now, this is often filled, or not often. It's sometimes filled. Sometimes it's not. And by the time you're in the fifth, sixth energy level, you're so far away from the nucleus that these are just like the energies of this are very similar to energy of that. So it's just, I don't know. I have a reason. I don't know if anybody has a reason. The filling order by the time you get down that far. All right. In fact, it's so uncommon. I don't know what that is, and I need to. I didn't even expect that. So I'm gonna be right back and copy and paste the transition metals down here. All right, I'm back. So let's just get through this. There's the one right there. There's the 2. There's 3. There's 4. There's 5. There's 6. All right, there's your answer. Okay, because it says 5D1 is right, 5D1, and then 4F7. And so it went through there, 5D1, and went through all of this, and that's number 64.